A survey found that women's heights are normally distributed with a mean of 63.8 inches and a standard deviation of 2.4 inches. A branch of the military requires women's heights to be between 58 inches and 80 inches. For Part A, it says find the percentage of women meeting the height requirement, and are many women being denied the opportunity to join this branch of the military because they are too short or too small. So let's go ahead and start this. So the first thing we want to do is draw a picture. So I'm going to draw our bell curve. Okay, and so in the first part of the question, they're telling us the mean is 63.8 inches. So we know the mean is 63.8. And we are also given the standard deviation to be 2.4 inches. Okay, so it's telling us that we want to be able to find the probability, the percentage that's between 58 inches and 80 inches. So if we make note here that x1 represents 58 inches, and then we would say that x2 represents 80 inches. Okay, so what we're interested in is finding the percentage or the area or the probability of in between those two values. Okay, so in order to do that, we want to be able to first find their z-scores. So we want to find the z-score for x1, which is 58. We know that the mean is 63.8. And we know that the standard deviation is 2.4. So to find z-score 1, we're going to take x1, subtract the mean, and then divide it by the standard deviation. So we have 58 minus 63.8, and then we're going to divide that by 2.4. So let's go ahead and do that. 58 minus 63.8, and then we're going to divide that by 2.4, and that gives us negative 2.42 rounded to 2 decimal places, so negative 2.42. Okay, now let's find x2, or the z-score for x2, because we know that it's 80. Again, we know the mean is 63.8, and the standard deviation is 2.4. So using that formula for z2, we're going to take x2 minus the mean divided by the standard deviation. So 80 minus 63.8 divided by 2.4. So 80 minus 63.8, and then we're going to divide that by 2.4, and that gives us 6.75. Okay, so let's go ahead and write out that z-score. So z1, z2, and we know that the mean is going to equal 0. So z1, that corresponds to the x value of 58, is negative 2.42. And the z-score associated with 80 is 6.75. So therefore, what we want to do is find the percentage between those values. So we want to find the probability where the lower limit of z is 2.42. and the upper limit is 6.75. So let's go ahead and do that, and we're going to use StatCrunch. So we're going to go to Stat, Calculators, and scroll down to Normal. We want to find the area that's in between those two values, so we're going to select Between. We have a mean of 0, a standard deviation of 1, and so we know our lower limit is negative 2.42. We know the upper limit is 6.75, and then we're going to round that to 4 decimal places, and that gives us 0.9922. So 0.9922. Okay, so it says the percentage of women who meet the height requirement is, so we need to convert that to a percent and round it to 2 decimal places. So in order to do that, we know that the probability is the same thing as area, it's the same thing as a percent. So if we multiply this by 100%, then we would get 99.22%. So therefore we would say 99.22%. Okay, now the question says, now are many women being denied the opportunity to join this branch of the military because they are too short or too small? Well, you can see here, since it's 99.22%, there's a very small percentage of women that are not allowed to join. So we would say no, because only a small percentage of women are not allowed to join this branch of the military because of their height. Let's go ahead and select that, and there's our answer. Okay, now the next question says, if this branch of the military changes the height requirements so that all women are eligible except the shortest 1% and the tallest 2%, what are the new height requirements? So for this question, what they want us to do is they want us to find the two values. So we need to find x1 and x2, but we are given the areas in this case. It says the shortest 1% and the tallest 2%. So let's go ahead and draw our graph to make sure that we want to know what this looks like. So for part B, we're going to draw a new picture, but in this case here, this new sketch only gives us the area. Okay, so let's take a look here. So it says we want to find out would be eligible as the shortest 1% and the tallest 2%. So that means that the shortest 1% would then have an area as a decimal of 0.0100. So that's going to represent the area that we want to find here, because that is the shortest 1%. And the tallest would be 2%. And so for 2%, we would change that decimal to be 0.0200. So that means that this area and then this area, those are going to represent the following. So we are given the fact that this represents that area, and then we know that this represents that area. So what we're trying to do is we're trying to find the values of, let's say, x1 and let's say x2. Okay, now we are given the mean and the standard deviation, so we know that the mean is 63.8, and then we also know that the standard deviation is 2.4. Okay, so for this question we got to go just a little bit backwards. So what we're trying to do is not backwards, but just go in a backward way of solving. Okay, we know that if this is going to have a z-score associated with x1, and x2 also has a z-score that's associated with x2 when we know the mean of the z-axis is 0. So if we're given the area, then we can find the z-scores, and then those z-scores will then allow us to then be able to find the values of x1 and x2. So let's go ahead and first find the z-scores. So the probability of z-score 1, okay, is going to have an area that's less than or equal to, we don't know what that is, but we know that the area is equal to 0.0100. Okay, and if we want to find the z-score 2, you can see that the area is shaded to the right, so it's greater than or equal to, and we're given the area to be 0.0200. And so our goal here is to find the z-scores, and we can use StatCrunch to do that. So let's go ahead and open up StatCrunch. Okay, and now what we want to do is we're going to go back to the standard here, and we have, it says less than or equal to, we have 0, 1, and then we're going to put the area in because we're looking for the z-score. So it's going to be 0.01, oops, let me do that again, 0100, and then press compute. And you can see here, if we round that to 2 decimal places, we get negative 2.33. So negative 2.33 is that z-score. Okay, And now what we want to do is we want to change this to be now greater than or equal to, so we can find this z-score. But we got to make sure that this area over here after the equal sign is changed to 0.0200, and let's select compute. And now rounding that to 2 decimal places gives us 2.05. So we get 2.05. Okay, so now what we want to do is, now that we have the z-scores, we can now find the x1 and the x2 by the given information. So we know that z1 is equal to negative 2.33. We know that the mean is equal to 63.8. And we know the standard deviation is 2.4. So using the formula to find x1, we know it's going to be the mean plus z-score 1 times the standard deviation. So let's go ahead and do that. So here we know the mean is 63.8 plus we're going to take the z-score of negative 2.33, multiply it by the standard deviation of 2.4. Okay, so let's go ahead and do that. So we're going to take 63.8 plus parentheses negative 2.33 times 2.4, and that gives us 58.208. So that's 58.208. Okay, now over here we know that z-score 2 was found to be 2.05. Again, we know the mean is 63.8, and we know the standard deviation is 2.4. So now in order to find x2, we're going to use that same formula. The only thing is the mean plus z-score 2 times the standard deviation. So we're going to take 63.8 plus 2.05 times 2.4, and let's see what that comes to. 63.8 plus 2.05 times 2.4, and that equals 68.72. Okay, so let's go back and take a look at what the question is asking us. And it says to round to 1 decimal place. So for the new height requirements, this branch of military requires women's heights to be at least in and at most what values. So what they're saying here is the following. Okay, we know that the values of x, okay, should be in between, rounded to 1 decimal place, 58.2 inches and 68.7 inches. So let's go ahead and put that in there. 58.2 and 68.7. So 58.2, 68.7. Check our results, and then there is our answer.